What up, guys? Yeah, the Nova community. By the way, thank you guys so much for always choosing us, supporting Nova. I really appreciate it with all of my life. This is has been incredible, and I'm hoping that you guys are actually learning a lot from Nova. And of course, I'm just hoping that you're telling your friends, your classmates, people from other schools. I'm drinking water. I know you. Okay, Team 100%, let's just get down to business. Now, they say the following sequence of numbers forms a quadratic sequence, right? Okay, so we have a quadratic sequence. So just write it down. So I'm going to have, what is this? It's going to be minus 3, and then there's going to be minus 2, and there's going to be, minus 3 again. This is weird. Okay, and now I'm going to have minus 6, and then I'm going to have minus 11, and this series is going to continue just like that. Before we go any further, they say the first differences of the above sequence also form a sequence. Determine the expression for the general term for the first difference. Also, they just want us to find the nth term of the arithmetic progression that forms, from the first difference, right? So what are we going to do? We're going to draw this pattern right here like this. Something like this, right? So I'm going to start. What is minus 11 minus 6? It's going to be minus 5, right? And then what is minus 6 minus 3? It's going to be minus 3. And then what is minus 3 minus 2? And it's going to be minus 1. And what is minus 2 minus 3? And just going to be 1. And this is the first difference that they were referring to. So this is the first difference, right? This is the ones difference. I remember talking about this. This is the first difference. And the first difference forms an arithmetic, right? Now, before we just go down to business, let's just continue with what we're doing, because we are still going to find the difference between this. So I'm going to have minus 5 minus 3, which is just going to be minus 2. What is minus 3 minus 1 is just going to be minus 2. And what is minus 1 minus 1 and just going to be minus 2. So this is what we call the second difference, right? This is what we call the second difference. So what the question wants us to do is to find the nth term for this expression, right? So how are we going to do that? I'm just going to say we all know that Tn equals to an squared. Oh my God, what am I doing? Tn is going to be a plus n minus 1 is to d. So Tn is going to be the value of a. As you can see, it's 1, right? So I'm just going to write that 1 plus n minus 1. And the value of d, it's simply going to be minus 2, because this is the second difference that we're talking about. So Tn equals to 1 plus, just going to multiply this, is going to be minus 2n. And then multiply this, we're going to have plus 2. And then to avoid confusing people, although it's the same, let me just not confuse people and just erase this, because some people will be like, Marvel, and I'll be tired. And then I'm going to have minus 2n. What is 1 plus 2? Just going to be 3. So this becomes the expression for this problem, right? And now let's look at this second problem, right? So the second problem says we need to calculate the first difference between the 35th and the 36th term of the quadratic sequence. We need to calculate the first difference between the 35th and the 36th term of the quadratic sequence. Oh, okay. Let me show you something, guys. This is T number 1. This is T number 2, this is T number 3, this is T number 4, and this is T number 5. What do we realize? In fact, let's just do this. Let me just, add the 2. I'm just going to call this one X and Y, and then this is going to be T number 6, and this is going to be T number 7, right? This is going to be T number 7. So I want to give you an example. When they say we need to calculate the first difference between the 35th and 36th term of the quadratic sequence, they want us to calculate the 35th term, of the arithmetic progression. And in fact, I want you to mark this. Whenever they say calculate the first difference between the 35th and the 36th term of the quadratic sequence, they want you to calculate what? T35 of arithmetic. That's what they want you to do. So let's say they would have said calculate the 38th and 39th. So what they would have wanted you to do is to calculate what? The T38 of the arithmetic progression. So I want you to do that one on your own. Calculate T35th. In fact, let's just do it. I'm going to say T35th equals to minus 2. Yeah, on n you're going to write 35th and then you're just going to write 3. And that just becomes your answer. Okay. That's some stuff you've learned in grade 11. Okay, let's just look at this. They say we need to determine an expression for the nth term of this quadratic problem, right? So we need to find the nth term for this quadratic problem and how we're going to do it. So we all know that Tn is given by an squared plus bn plus c, right? Now, what is the value of a? The value of a is simply going to be, I do not know. But I've told you something, right? I said each and every single time, you need to say 2a equals to what? It equals to the second difference. And at this point, the second difference is going to be minus 2. So therefore, you're going to have minus 2. So you're going to divide both sides by a 2. So therefore, the value of a equals to minus 1. Can you see it? Now, what is the next thing you do? You need to do this. And you need to say a plus b plus c equals to the first term, right? And the first term here is going to be minus 3. So you're going to say this is minus 3. I think we just need to leave it at b. And then you're going to say 4a plus 2b plus c. It's going to be the second term, and the second term is just going to be minus 2. It's just going to be minus 2. You know what? Let's just leave it at b, right? Let's just leave it at 2. We should go further to 3, but, let's just leave it at 2. So here we're going to say, what is 2 minus 1, right? So 2 minus 1 means that we're going to have this expression number 2 minus expression number 1, right? So we're going to have what is 4a minus a. Therefore, we're going to have 3a. What is 2b minus b is going to be b. And c minus is just going to be 0. And we're going to have what is minus 2 minus 3. So minus 2 minus 2 minus 3 is just going to be a 1. So we're just going to have a 1. And we quickly realize here, we quickly realize that, wait, we do have the value of a. It's minus 1. So wherever there is a, we're just going to substitute minus 1. So 3 minus 1 plus b equals to 1, right? So we're going to have minus 3 plus b equals to a 1. So of course, we're just going to take this to the other side. So we're going to have b that actually equals to a 4. So now you have the value of a that equals to minus 1 and the value of b that equals to a 4. How can we find the value of c? So the value of c can be deducted from this expression, right? That says a plus b plus c equals to minus 3. So what is the value of a? The value of a is minus 1. The value of b, it's a 4. We just want to find the value of c that equals to minus 3. So what is minus 1 plus 4? So minus 1 plus 4 is just going to be a 3 plus c equals to minus 3. So if we take this to the other side, the value of c is just going to be minus 6. So now we could say, therefore, right, Tn equals to the value of a, which is minus 1. So we're going to have minus n squared plus the value of b, it's a 4. We're going to have 4n. The value of c, it's minus 6. So we're going to have minus 6. So that's how we identify the nth term of the quadratic problem, right? Now let's just look at this. The last question says, explain why the sequence of numbers will never contain a positive term. Ooh, okay. Okay, this is good. This is good. By the way, I'm doing these things for the first time. I didn't answer this question before, you guys. So I want to show you this, right? So we are having this expression. I just want to copy it down here. We are having this expression to be what? Minus 3 to be minus 2 to be minus 3 to be minus 6 to be minus 11. You realize this expression is just becoming more negative, right? And the question says we need to explain that. Why is it that we need to explain why the sequence will never, you see this never, contain a positive term? Why is that? Now the answer lies between the Tn. Let's just copy it down. So Tn equals to minus n squared plus 4n minus 6, right? Let's just take it from here. What do we realize? The reason why this expression will never contain a positive term, here it is. It is because the value of a equals to minus 1. That's the reason. Now, I want to explain that. Let me explain that. Let's say we say Tn. Let's take out the common factor of a negative from this expression, right? Let's just take out the common factor of a negative. We're going to have a negative, then brackets n squared plus 4n minus 6. What is the thing that we need to remember? We need to remember that the value of n, can you see this value of n, will always be a positive because the 10th number cannot be a negative. For example, let's say that you are writing a math test on your class. Your class has 50 learners. Is it possible for you to be on position minus 3? It's not possible, right? Is it possible for you to be on position minus 9? No, it's not possible. It's either you are top 1, top 2, top 3 until top 50, right? So it's the same thing with this nth term. The nth term, then the value of n, the value of n will always be positive, right? This value of n will always be positive. So because of that, any number that will be generated from here, I want to show you this. Any number that's going to be generated from here will always be a positive. I want you to put 1 where there is n. Let's put 1 here where there's n. Let's forget about this negative and let's just put 1 where there's n. I want to show you something. If we put 1 and then we say squared plus 4 and then we just say 1 and then we say minus 6, what do we get? We get minus 1. We're going to get what? A minus 1. This is what we get. We're actually going to get minus 1. Now, I want to show you this. Oh yeah, here it is. It's going to be a 1. But moving from T2, right? Moving from T2, the expression will always be a negative. And why is that? I think it's not starting from 1, it's starting from T2. So starting from T2, the expression will always be what? A negative, because any number that you're going to put in terms of the value of n, it's always going to be a positive. Put 2 here, you're going to get a positive. Put 3 here, you're going to get a positive. Put 4 here, you're going to get a positive. But wait, what is happening here? Because all the numbers that you're going to put from T2, it's going to be a positive. Those numbers will be multiplied by this negative. So therefore, this expression will always be a negative because any number from T2 will always be greater than 0. So it will always be positive. And because of this negative, it will multiply that number by a negative. So the number will just be a negative. So no matter what number you put from T2 to positive infinity, the answers will always be a positive, and then they would be multiplied by the negative, and they would just always be a negative. So that's why the expression will never contain a positive number from T number 2.